Welcome to another video. Let's call this part 2 of the infinitely nested radical video series. Well, that's a long title. And the reason why I'm going to call it part 2 is because there's going to be another part, or maybe 2 other parts, where we're going to start dealing with the general formula to solve them. The problem with knowing the formula is the formula is not sufficient to solve all the problems. It is just there. You have to know how to use it. Now, if you don't know the form of the nested radical, you don't know how to use it or what to plug in. So understanding how these nested radicals are formed is the key to using the formula provided by the great Ramanujan. Let's get into the video. So like I did in part 1 of this video, I am going to do the same thing in this video. I am going to show you how this was generated and how you can make your own nested radicals. Okay, let's do it again. So now this time, your natural numbers don't have to be greater than 1. You can use n equals 1 because we're going to be adding and subtracting also. If you recall, okay, let's just be safe. Let's n be greater than 1. In the last example, remember I did something like this. I said n is the same thing as the square root of n squared. And what I did to n squared was I subtracted n and then added n just to balance things out. But now I'm not going to be using n as the balancing factor. I'm going to be using a number, the easiest number in the world. Yeah. It's the number 1. So watch this. I could say, hey, this is the same thing as the square root of n squared minus 1. But because I know that subtracting 1 from n squared has destroyed the integrity of the original number, I have to add back the 1. So what does this look like? This looks like, you know what? Let's make it nicer. I'm going to bring the 1 first. So it's going to be 1 plus n squared minus 1. This is still the same thing as this, and it is still n. But if I factor this, I'm going to get the square root of 1 plus, what is this? This is n minus 1 times n plus 1. Nice. Now, what you're about to see is not magic. I want you to follow what I'm doing, because if we retain the same n, things are going to change. So, look, this same n, which we have transformed into this, all the way to this, we can write it as exactly what you see here. It is the nested radical. Let me make a giant radical because we're going a long way now, okay? And then we can solve this, and it will be the end of the video. And in the next one, I'm going to focus on Ramanujan's formula, and also I'm going to show you how to prove, maybe in another video, whether a nested radical is convergent or divergent. That's going to be crazy a little bit. So it might be the very last thing I'm going to do, because almost all of them converge unless some tiny little things happen, and then they may diverge, but most of them will converge. Okay. Now, so we got n equals 1 plus, you see, this is going to be n minus 1. Nice. There's nothing wrong with that. Multiplied by n plus 1. But I don't want to write n plus 1. Okay? I don't want to write n plus 1. Remember, n plus 1 is the number after n. So let me assume it is the number, let's use k, just for simplicity. Okay? So instead of me writing k, I don't want to write k. I want to make a nested radical for k also. And remember, once it is k, you can come here and just use the same thing. So I can say, hey, this k, I can replace this k just like I can replace n with the radical. Watch this. Ta-da-da! Now this radical is going to follow the same format. 1 plus k minus 1 multiplied by k plus 1. Okay? But, hey, what did we say k was again? K was n plus 1. So actually, if I want to write this k here, I should be writing n plus 1 minus 1. So n plus 1 minus 1 just has to be n. So instead of writing k plus 1, it's going to be, k minus 1 is n plus 1 minus 1. So it's just n. So I'm going to replace this with n, and then the next one is going to be, oh, I have to replace this also. I just wanted to see how to build this. So this indeed is 1 plus n times, this is k minus 1, k plus 1. So this is 1 plus n times n plus 2. That's what this is going to be. But this n plus 2, again, we're going to change. So what you notice is this number is going to be n minus 1. This number is going to be n. The next one you have is just going to be 1 more than it, and you will just keep going forever. Okay, let me write this correctly. So this is going to be 1 plus n times the radical of 1 plus n plus 1 times the radical 1 plus n plus 2 times the radical. I need to keep on going like that. 1 plus, tap, tap, tap. Okay, like that. This is what this will be. It is still the same n, but it's coming in a different form. Look, 1 plus n minus 1, 1 plus n. This is 1 plus n plus 1, 1 plus n plus 2, and it goes on forever. You do the work yourself, you will notice that this radical, this number here, can be written in this form. So remember, I said no formula in this video. We're just going to do it by observation. We created this. We're going to compare this to what we have here and see. Okay, let's make things a bit easy. Let's try to create a bunch of infinitely nested radicals. Starting from, let's say n is equal to 1. If n equals 1, then this is going to be 1 plus 0 times 1 plus 1 times radical 1 plus 2 times radical 1 plus, you see that? So we can easily say, let's just do examples. We can easily say that the infinitely nested radical of 1 plus 0 times the radical of 1 plus 1 times the radical of 1 plus 2 times the radical. We just keep going. What do you think the answer to this is going to be? Clearly, once you've multiplied 0 by anything, everything becomes 0. So the answer to this is just the square root of 1, which is equal to 1, which is equal to the assumption we made when we started. Let's move on to 2. If this is 2, then this is going to be 1 plus 1 times the radical of 1 plus 2 times the radical of 1 plus 3. So we can do the same thing. This is going to be the radical of 1 plus 1 radical 1 plus 2 radical 1 plus 3 radical tap, tap, tap. And what's the answer? The answer to this is going to be, oh, let's even say we stop here. Well, maybe not. I don't know. But it looks juicy. Okay. Okay, let's leave it. Okay, so this is going to be, because we said n equals 2, this is going to be 2. You notice that the solution to our problem is showing up here. And that is where this n is. So when you get a radical that looks like this, just pay attention. As long as you have positive signs and there is a linear increase, there's a gradual increase, a unit increase every time here, and you have 1, 1, 1. If you don't have 1, 1, 1, the only suspicion you should have is that we did not use -1 and 1 for this modification. Whatever number you have here must have been the modification used for the square. Remember, it has to be a radical, not cube. For the cubic one, there's another way you have to do that. So let's look at the problem we have. Let n be equal to 3, and I think that's the answer to this one. As you can see, it's occupying that position. So we have the radical 1 plus, we got, it's going to be 1 plus, when n equals 3, 3 minus 1 is going to be 2, radical of 1 plus 3 radical, 1 plus 4 radical, tap, tap, tap. Well, as expected, our answer is supposed to be 3, and this goes on forever and ever. So you say, well, you didn't show me how to solve this. Well, the other option is to use the formula, which you have to memorize and have to know how to use. But this makes you better equipped to know how to use the formula. I'll see you in the next video. Never stop learning. Those who stop learning, stop living. Bye-bye.